I want you to take a second and just picture your dream home renovation.
Okay.
You're probably scrolling through Pinterest, right? And what do you see?
Oh, the waterfall quartz countertops. Yeah, for you.
Exactly. Or maybe you're finally tearing down that wall for the open concept living room. We spend so much time and money on the things we can see, the things we can touch, but looking at this research you brought in today, I feel like we are completely missing the point.
Well, we're effectively polishing the skin while ignoring a serious heart condition.
That is a terrifying way to start this, but looking at these articles, it feels pretty accurate.
It is.
We're doing a deep dive today into what our sources are calling the silent conductor. We're talking about the electrical network inside your walls.
Yep.
We've got a whole series of advisory articles and safety data here from AT Electric LLC, and they're focused on home efficiency and safety right there in the Mansfield, Texas area. And the picture they paint it's pretty stark.
It is, because the core issue is really psychological. We treat electricity like a set-it-and-forget-it utility.
Right.
You flip a switch, the light comes on, you plug in your phone, it buzzes. You don't think about how it happens.
I never think about how it happens. I just get annoyed when it doesn't.
Exactly. And that mindset is a gamble.
Yeah.
The sources actually compare the electrical system to the human bloodstream.
Oh, interesting.
If the flow stops or if it gets blocked somewhere, the house it effectively dies. But unlike your plumbing, if a pipe bursts, you know immediately.
You're standing in a puddle.
You're standing in a puddle.
Yeah.
Electrical failures are silent. They hide behind the drywall, sometimes for years, right up until the moment they become catastrophic.
So let's pull back that drywall, metaphorically speaking. The research really centers on the electrical panel, the breaker box.
Right.
For me, and I assume for most people listening, that is just the ugly gray metal box in the garage that's usually blocked by holiday decorations.
Or old paint cans, which is the first mistake, by the way. You need clear access to it. But functionally, think of that panel as the heart of your home.
Okay.
It's not just a passive thing. It's a regulator. It decides how much power goes where. It's the gatekeeper. And the biggest misconception that AT Electric points out in this research is the idea that the panel is a static object.
Well, it is static, isn't it? I mean, it's a metal box. It's bolted to a stud. It doesn't move.
That's where you're wrong. And this is where the physics gets kind of fascinating.
Okay.
It's a mechanical system. And it's subject to physical laws. You have to remember, electricity generates heat.
Right.
Every time you run your dryer or your AC kicks on during a hot Texas summer, the wires inside that panel heat up.
Sure. Okay. Resistance creates heat. I remember that from high school physics.
Exactly. But materials expand when they get hot, and they contract when they cool down. So copper, aluminum, the metals in your wires, they move.
Wait.
They are constantly expanding and shrinking. Expanding and shrinking.
So the wires inside my wall are breathing.
Essentially, yeah. And this process is called thermal creep.
Thermal creep.
Over 5, 10, 15 years, that microscopic expansion and contraction can physically unscrew the connections inside your panel.
No way.
Yes. The screw that was tight in 2010 might be loose today. Not because anyone touched it, but because the physics of the wire just worked it loose.
That is a wild mental image. The idea that my house is just vibrating its own screws loose by existing.
Pretty much.
So this brings us to what the sources call the big 4 reasons for an inspection. And based on what you just said, I'm guessing fire prevention is number 1 for a reason.
It is the critical one. And it ties directly back to that loose screw.
Okay.
When a connection gets loose, the electricity, it still tries to flow. But now there's a gap. So the electricity has to jump across that gap. That's called an arc.
Like a spark.
Think of it as a tiny, sustained lightning bolt. And just like lightning, it is incredibly hot. We're talking thousands of degrees at a micropoint.
Whoa.
That heat melts the insulation on the wire, and eventually it ignites the materials around it. And remember, this is all happening inside a metal box.
Inside a wall?
Usually inside a wall. So you don't see the smoke until the fire is already established.
That completely changes how I view an inspection. I'll be honest, I always thought of an electrical inspection as a formality. A guy comes in with a clipboard.
Glances at the box.
Yeah, slaps a sticker on it and charges you a fee.
And if that's the inspection you're getting, you are getting ripped off.
Okay.
The sources detail what a real inspection looks like. It involves a screwdriver and a torque wrench. They are literally going into the panel and tightening those connections.
So they're physically tightening them.
Down to manufacturer specifications to counteract that thermal creep. It's active maintenance, not just a visual check.
That distinction is huge. It's not a checkup, it's a tune-up.
Exactly.
Which, okay, that segues into their second point, code compliance. Now, I have to be honest, when I hear code compliance, my eyes just glaze over. It sounds like bureaucracy.
I get that. It does. It sounds like red tape. But
Yeah.
I want you to reframe code in your mind. Think of the electrical code as a history book of things that went wrong.
That's a grim way to look at it.
But it's true. Codes are safety rules.
Yeah.
Yeah, they're written in ink, but they're usually drafted in response to disasters. What was considered safe 15 years ago isn't considered safe now
Why not?
because our understanding of risk has evolved.
Can you give me an example of that? Like, what's something my old panel might be missing?
Sure, arc fault circuit interrupters, or AFCIs.
AFCIs.
They're smart breakers. They don't just trip when there's too much power. They actually listen to the signature of the electricity.
They listen.
Yeah. If they detect that chaotic pattern of an arc, that tiny lightning bolt we talked about, they cut the power instantly before fire can even start. An old panel from the 90s. It's blind to that. It doesn't know the fire is starting until the wire physically melts.
That makes so much sense. It's like seatbelts or airbags. Cars didn't always have them, but once we knew better, we decided they were non-negotiable.
It's the same principle.
Yeah. Now, the third point in the big four is overloaded circuits. This one feels personal. I'm looking around my office right now, and I have a lot of stuff plugged in.
We all do. And this is just a math problem. A standard circuit can only handle so much flow.
Right.
Think of your wiring like a highway. It has a set number of lanes.
And 20 years ago, traffic was light.
Exactly.
Yeah.
You had a TV, a fridge, maybe one desktop computer, some lamps. Today,
Oh, man.
you have 2 monitors, a gaming PC, high-speed routers, smart speakers in every room, kitchen appliances that draw massive power. An air fryer isn't just a gadget, it's a high-draw heating element.
My air fryer sounds like a jet engine taking off, so that checks out.
So if you find that you're tripping breakers constantly, it's easy to get annoyed at the breaker,
Yeah.
but the breaker is doing its job.
Yeah.
It is screaming for help. It's cutting the power to save the wire from melting because you're trying to push rush hour traffic down a single-lane country road.
And the fourth point is basically just avoiding the headache of an outage.
Right, but think about the cost, too. If a main breaker fails during a Texas freeze or a heat wave because it hasn't been maintained, you're not just uncomfortable.
You're looking at burst pipes.
Burst pipes, spoiled food, maybe a hotel stay, it gets expensive fast.
Okay, so we know why we need to look at the panel. But
Yeah.
how do we know what to look for? The sources list some specific warning signs, some sensory details that tell you to call a pro immediately.
These are the red flags you absolutely cannot ignore. The first one is sound, auditory. Your electrical panel should be dead silent.
Okay.
If you walk past it and you hear buzzing or humming or a sizzling sound,
Run.
well, don't run, but do not ignore it. That sound is the electricity harnessing. It is the sound of the current struggling to jump a gap.
The little lightning bolt.
That buzz is literally the precursor to a spark.
Okay. Silence is golden. What about smell?
If you smell burning near your panel, you're likely already in a danger zone. The sources describe it as an acrid smell.
Like chemical.
Distinctly chemical, yeah. Like
Yeah.
burning plastic or ozone. That means the heat is already intense enough to melt the insulation on the wires.
And visual. I mean, I assume scorch marks are bad.
Scorch marks are the smoking gun, for sure. But also, look at your lights. We've all been in a house where the lights dim for a second when the AC kicks on.
Yeah, that browning out thing.
Right. A tiny momentary dip might be normal in some older setups.
Yeah.
But if you have consistent flickering, or if the lights in the kitchen dim when someone vacuums in the bedroom, that suggests a systemic issue with the panel.
Huh.
The heart isn't pumping blood evenly to the extremities.
Now, there's a specific number that gets mentioned in the source material that acts as a sort of hard threshold. The 20-year rule. Why 20 years? My house was built in 2004, and honestly, it still feels pretty modern to me.
2004 feels modern, but think about the tech landscape in 2004. Did you have a smartphone?
No, I think I had a flip phone. Maybe a BlackBerry.
Did you have an electric vehicle charging in the garage? A robot vacuum? Smart switches?
Definitely not, no.
That's the issue. Homes built before that 20-year mark were designed for a different era of consumption. The source material is really blunt here. If your home is over 20 years old, your electrical system is likely struggling.
Struggling.
It might technically work, but it's running a marathon in wooden clogs.
Wooden clogs. That's a great image. It works for a few steps, but eventually you're going to break an ankle.
Exactly. You are running a modern digital life on analog-era infrastructure.
Yeah.
And it's not just capacity. It's about those safety features we mentioned, like arc fault detection, that older panels just don't have.
Let's shift gears a little. We've been talking a lot about the heavy, scary safety stuff, fires, melting wires.
Yeah.
But the source material from AT Electric also dives into the intersection of engineering and aesthetics. They have this great breakdown on the wobbly fan.
This is a classic example of where the do-it-yourself mindset can collide with physics.
I was going to say, installing a ceiling fan seems like the classic Saturday afternoon dad project.
Yeah.
You buy it at the hardware store, you wrestle it onto the ceiling, you call it a day.
And the sources argue that it should be treated as a high-stakes engineering project.
High-stakes engineering for a ceiling fan.
Think about the forces involved. You're not just hanging a static picture frame. You're suspending a heavy motor with spinning blades.
Okay.
When you turn that fan on, it creates torque. It twists. It creates vibration. The source uses a really vivid image here. 10 pounds of crystal crashing onto your dining room table.
Yeah, that is a dinner party ruined instantly.
And the failure point usually isn't the fan itself. It's the box in the ceiling.
The electrical box.
Yeah. Standard electrical boxes, little blue or metal cups, they're designed to hold a light bulb. They're rated for static weight. If you screw a heavy vibrating fan into a standard box, the vibration will eventually work the box loose from the joist.
So you need a specific kind of box.
You need a fan-rated box. It has heavy-duty bracing bars that actually dig into the ceiling joists. It's designed to handle that dynamic torque.
The sources also point out the regional context of, Mansfield and North Texas here. Why does geography matter for a ceiling fan?
2 reasons. First, the humidity. We have wild humidity swings here.
Yeah.
That causes the wood in your attic to expand and contract, which just makes that loosening effect even worse.
Okay.
And second, the architecture. You look at homes near Joe Pool Lake or Walnut Creek, what do you see?
Giant foyers, massive great rooms.
High ceilings. We're talking 18, 20-foot ceilings. Installing a fan at that height isn't something you do with a stepladder and a prayer.
No.
It requires structural understanding. If a fan falls from 8 feet, it breaks the table. If it falls from 20 feet, well, the physics are a lot less forgiving.
Speaking of ceilings and aesthetics, let's talk about lighting. The sources get pretty opinionated about visual noise. They seem to have a vendetta against bulky chandeliers.
And dated track lighting, yeah. This connects to that whole trend of minimalism.
Right.
The goal is to see the light, not the fixture. The source calls recessed lighting or can lights the ultimate secret weapon for this.
Because they disappear.
Exactly. By tucking the fixture into the ceiling, you reclaim all that visual space. It makes a room feel larger, airier, because your eye isn't getting snagged on a giant brass thing hanging in the middle of the room.
I usually think of lighting as just, being able to see, but they frame it as a design tool.
It's about control. Old lighting is often just on or off. Modern recessed lighting allows for zoning.
Zoning.
You can dim the lights over the TV while keeping a reading nook bright. You can wash a wall with light to highlight a painting. It transforms lighting from a utility into a way to shape the mood of the room.
Now, since we're talking about the Texas context, there's a really poetic line in one of the articles that caught my eye. It said, "A Texas sunset is a countdown."
That's a powerful image.
Yeah.
It speaks to the duality of the environment here. The sunset is beautiful, but once that sun dips below the horizon, the property transforms.
It becomes a security issue.
Absolutely. Without proper lighting, a stunning limestone facade just disappears into the dark. But more importantly, the home becomes a target. The source argues outdoor lighting isn't just a porch light, it's a strategy.
A strategy for what?
Command and control. If you have a dark lawn, it's a void. If you have a properly lit perimeter, you deter intrusion. It signals that the home is occupied, that it's monitored. And this applies even more heavily to the commercial side. In the winter, the sun sets at 5:30 p.m. here.
That rush hour darkness, it feels like midnight when you're leaving work.
Exactly. So if you own a business and your parking lot is dark, or, and this is almost worse, lit by those buzzing orange-hued high-pressure sodium bulbs.
Oh, I know exactly the ones. They make everything look sickly and vaguely like a crime scene movie.
That's actually a technical issue. It's called color rendering index, or CRI. Those old orange lights wash out color information. A red car looks gray, a blue shirt looks black. It disorients people and makes them feel unsafe.
Because they can't identify their surroundings clearly.
Exactly. So upgrading to LED in a parking lot isn't just about saving a few bucks on the electric bill.
No.
No. The source makes a hard-nosed business case here. If your lot is dark or orange, you look closed even when you're open. You switch to crisp, high CRI LEDs, you look open, safe, inviting. The ROI isn't just energy savings, it's customer traffic.
You are literally inviting people in with light.
Yeah.
It's interesting how lighting bridges that gap between making things look nice and keeping people safe.
It's the ultimate multitasker in home improvement.
There is one more invisible threat we need to cover. We talked about the panel, but what about the stuff plugged into it?
Right.
We touched on this with the modern digital life concept, surge protection.
This is a huge blind spot for most people. We tend to think surge protection means buying a $15 power strip and plugging our computer into it.
That is literally what I have under my desk right now. I feel called out.
And that's fine for the computer, maybe.
Okay.
But what about your smart fridge? What about your washing machine? What about the HVAC system in the attic?
I never thought about my dishwasher or my AC unit as electronics. They're just machines.
That was true 30 years ago. Today, you open up your dishwasher, you'll find a motherboard. Modern appliances are computers that happen to wash clothes or cool air.
They have microprocessors.
Sensitive microprocessors. And a power strip behind the couch can't protect the circuit board inside your dishwasher.
So what's the solution? You can't put a power strip on a hardwired appliance.
The source advocates for whole house surge protection. This is a device that gets installed at the panel level, back at the heart of the system.
So it stops the surge before it even gets to the outlets.
Exactly. It acts as a gatekeeper for the entire house. And here's the thing. People think surges only come from lightning.
That's the assumption, yeah.
In reality, most surges come from inside the grid, or even from inside your own home. When your AC compressor kicks on, it can send a voltage spike back through the lines.
Wow.
And without protection, that spike can fry the sensitive control boards of your other appliances in an instant.
And when you do the math, the cost of replacing the motherboard on a smart fridge and the control board on an HVAC unit is
Astronomical. Thousands of dollars. Compared to the cost of installing whole house protection, it's the cheapest insurance policy you can buy for your home.
So we've unpacked a ton here. We've gone from the thermal creep in the breaker box to the torque of a ceiling fan, out to the parking lot security, and back to the surge protector. If we had to synthesize all this for the listener, what does it all boil down to?
I think it boils down to 3 core values: safety, efficiency, and peace of mind.
Safety being the fire prevention, the shock hazards.
And non-negotiable. Efficiency is about your wallet, lowering utility bills by making sure you aren't wasting power through heat or using old bulbs. And peace of mind.
Yeah.
That's the big one.
Peace of mind is just knowing that when you flip a switch, it works, and it's not going to hurt you.
Precisely. It's knowing that the silent conductor isn't secretly plotting a failure behind your wall.
And the mechanism to get those 3 things is the inspection.
Right. But a real inspection. It's moving from a reactive mindset, I'll fix it when it smokes, to a proactive one.
Right.
A professional inspection, where they actually tighten the screws and test the load. It extends the lifespan of the entire home system. It's arguably the most valuable maintenance you can do because everything else in your house relies on it.
It's funny, we started this talking about how we worry about curb appeal.
Right. The limestone, the paint.
The landscaping. But we completely ignore the bloodstream that keeps the whole house alive.
We just take the miracle of electricity for granted.
Yeah.
We expect it to be infinite and instant, but we forget it needs care.
So here's my challenge to you listening right now, tonight, when you get home, or if you're home now. Go find your breaker box. Move the storage bins. Just look at it. Open the door.
Take a sniff. Listen for a buzz.
If you don't know the last time a professional looked at it, it has probably been too long. The electrical panel is the heart of your home. When was the last time you checked its pulse?
That's the question.
It might be time to look at that gray metal box with a little less annoyance and a whole lot more respect. Thanks for diving deep with us today.
Catch you next time.